Hello and welcome to Learn Redis with Python and Django. I'm Xander and I'll be your guide throughout this course. Now this tutorial is part of a full course playlist available for free on YouTube. For a deeper, more structured learning experience, the complete course is also available on Udemy. You'll find all the links and resources in the video description. Now don't forget to subscribe to the channel for weekly promotions, exclusive discounts and Udemy course giveaways. In this tutorial, we'll take a look at how Redis handles key expiration using commands like expire and TTL. So this topic is important because it helps you manage memory and data lifecycle efficiently within your Redis-powered applications. Right, so let's take a look at some examples. Here we're going to be working with Redis strings using basic commands to explore how keys can be set to expire, checked, updated, or removed. The goal is to build an understanding of how key lifetimes behave and how to control them precisely. Right, so let's first of all create some data. So set session user 101 active. So we'll go ahead and build that data. This data will simulate a logged in session for a user, and then we can go ahead and use expire. So expire. And then we need to identify the key. So that was session user and 1001. And now we can go ahead and set the lifespan to 60 seconds. Go ahead and run that. And now we can go ahead and use TTL. So TTL, this allows us to view or return the time left in seconds before the key is removed. So we need to make sure we just match the key correctly. We run and we can see that there are 44 seconds left. So we have seen examples of this in the previous tutorial. This is ideal for time-bound sessions or one-time access tokens. Expiry doesn't delete the key immediately. It marks it for removal after the duration passes. Now it is possible to check the expiration of any key. So let's imagine we create a new key value and then go ahead and use the TTL on this data. We can see what is returned is -1. And of course that can be very useful. TTL gives insights into how Redis treats each key and lets you verify if expirations are properly set. Right, so sometimes you want to stop a key from expiring. So let's go ahead and add a new key. So set alert email pending. So we create a new key and then let's set the expiration of it. So expire alert email 120, so 120 seconds. And now what we can do is use persist. So this will remove the timeout if you check it. So let's go ahead and use persist on our key, so alert email. So that returns integer 1. And now what we can do is run TTL to view the expiration of it. And you can see we have a -1, indicating the fact that the data will now not be removed after the expiration was initially set. So we get a -1 showing that the key is now persistent. So persist is useful when data changes in nature from temporary to permanent. Now, instead of using set followed by expire, Redis offers a few different shortcuts. One of them is to use set x. So this command will allow us to specify in seconds before the data is defined, a cache value here, a value which represents the expiration time, like I said, in seconds. So let's give this a go. We can see that it has been set. We can use get to return the data. Okay, so cached value is set. And then we can use TTL to review the current expiration time. So we run. And now you can see that we return -2. So we can now summarize and say in Redis TTL key returns a positive number if the key exists and has a remaining lifetime in seconds. It returns a -1 if the key exists but has no expiration, and a -2 if the key no longer exists. So the key has already expired and Redis has automatically deleted it. Now, the -2 doesn't always represent the fact that the key has expired. It could be a simple case that a script or process has manually deleted the key. So let's take a look at how expiration works or behaves with updates. So we'll go ahead and we'll create this login attempt user 42. So they have tried to log in just once, and then we go ahead and add the expiration time for 300 seconds. We'll go ahead and run that, and let's just go for an increment. So we're going to update the user login attempts by 1. We'll take a look at increment a little bit later on in this module. So now they've tried to log in twice. So the number is now 2. And then we can go ahead and run our TTL to see how much time we've got left. Looks like we've got 234 seconds left. The TTL still counts down from the original 300 seconds. Updating the value does not reset the expiration. You would need to manually reset it with another expire. Right, so we can work with both seconds and milliseconds for more precise timing. So for that, a few different approaches. So let's set the flash notice to hello, and then we can set the expiration time to 500 milliseconds. So let's go ahead and do that. So this time we're using the command p-expire. Now let me just change that a little bit to give us a little bit more time to show you the command. So we run this, and now to view this in milliseconds, we can use the p-TTL command, and that would then show us the milliseconds rather than what we saw previously where we're working in seconds. The last approach we have already seen using X and PX. If you remember, in the previous tutorial we used X and PX to set the expiration times. So X was used to set the expiration time in seconds, and PX was used to set the expiration time in milliseconds. So a quick example, set the temp key, you just see that, temporary, and then we define the EX option, and then the value here in seconds. And then of course in milliseconds, it's just changing that to PX and defining the value in milliseconds. So together, these examples form a picture of managing key lifetimes in Redis. You've now seen how to set, check, and control expiration with precision. So whether you're building time-sensitive logic or simply keeping your cache clean and lean.